Hello, everybody, and thank you for joining us for tonight's Tech Talk. Tonight we have Nick Suzuki, and he's going to be talking to us about his journey into Rust. But before he begins, let's please have everyone unmute and give him a big round of applause. Wonderful. All right, Nick, take it away.
Thank you, Adam, and thank you for everybody for attending my Tech Talk. Before I start, I would like to thank CodeSmith and singlesprout for sponsoring my Tech Talk. So to begin, let me tell you all about the goal of the Rust project, and that was to design and implement a safe, concurrent, practical systems language. The seed of invention was planted because at the time Rust was started, the programming languages at its level of abstraction and efficiency didn't pay enough attention to safety, there was poor concurrency support, there was a lack of practical affordances, and they offered limited control over resources. Rust exists as an alternative to provide both efficient code and a comfortable level of abstraction while improving all four of these points. I promise I'm going to circle back and decipher everything I just said, but before that, let me give you a map of our little journey today. So our first stop will be looking at the origin story of Rust, a little who, what, where, and when. Then we'll check out what Rust has turned into today. Then we'll go into the features of Rust, where I'll translate the things I just mentioned on the previous slide. Once we're done with that, I'll talk about the future of Rust. And then to finish off our journey, I'd like to talk about the resources and tools that one can use once they start experimenting with Rust. So a long time ago in the galaxy we currently live in the year 2006, there was a software engineer who specialized in compilers and language tools for Mozilla. His name was Graydon Hoare, and he is the creator of Rust. For the first few years of its existence, Rust was Mr. Hoare's part-time passion project. Hoare mentioned in an interview that because the modern internet was shifting to an environment that was highly concurrent and highly security conscious, he wanted to revive old ideas from languages of the past that were too advanced for their time. One thing that the Rust docs made very clear is that Rust does not employ any cutting edge technologies. Instead, the language employs old established technologies. This list mentions the different languages that influence Rust. Take note that some of the technologies have been deprecated during Rust evolution. After developing his project for a few years, Hoare showed the Rust prototype to his manager, and Mozilla started sponsoring Rust in 2009. And once the language was mature enough to run basic tests and demonstrate its core concepts, Mozilla officially announced Rust in 2010. The designers refined the Rust language while writing both the servo experimental browser engine and the Rust compiler. And in January of 2012, the first pre-alpha release of the Rust compiler was released. There were numerous pre-alpha releases that tinkered with Rust. Some elements were taken away, like type state and green threading, and much of the standard library's early design was rewritten to fully take advantage of Rust features and provide quality, consistent cross-platform APIs. Rust 1.0, the first stable release of Rust, was released on May 15, 2015. And since then, Rust has maintained 3 different release channels, a stable, beta, and nightly, on a train release schedule. This means that the stable and beta channels are updated every 6 weeks, with the current nightly channel becoming the new beta channel and the current beta channel becoming the new stable channel. The nightly channel gives early adopters access to unfinished features as they're being worked on, and that channel is updated on a nightly basis. New language and standard library features marked unstable or hidden behind feature gates may only be used on the nightly release channel. New features land as unstable and are ungated once approved by the core team and relevant subteams. This approach allows for experimentation while providing strong backwards compatibility guarantees for the stable channel. Stability and backwards compatibility are 2 very important goals of the language. Rust is so backwards compatible that it's expected if code compiles on Rust 1.0, that same code will compile on whatever the newest version of Rust may be. And things were going pretty well, but then the world changed. In August 2020, as part of corporate restructuring due to COVID, Mozilla laid off 25% of its workforce. Among those laid off were most of the Rust team that Mozilla employed. But since Rust was an open source project, a vast majority of the contributors weren't employed by Mozilla. However, times were still rough because Mozilla was a key sponsor of Rust and provided much of the infrastructure. They paid the hosting bill for the Rust package manager and owned the trademarks to most of the products associated with Rust. One thing in Rust's favor is at this point, there were many other tech giants that used Rust, including AWS, Microsoft, and Google Cloud. Would they allow Rust to fall into the abyss? And here we are at our second stop, Rust of the present. After 4 months of being in limbo, it was announced on February 8th, 2021, that Rust had a new home, the Rust Foundation, which was a nonprofit organization. The 5 founding companies of the Rust Foundation were AWS, Huawei, Google, Microsoft, and Mozilla. And the foundation had the primary purposes of supporting the maintenance and development of the language, cultivating the Rust project team members and user communities, managing the technical infrastructure underlying the development of Rust, and managing and stewarding the Rust trademark. Currently, there are 28 members in the Rust Foundation, and it's because of those members that Rust is able to grow and thrive. So I'm going to go over those 4 things I mentioned before. The first thing that Rust concentrated on was memory safety. But memory safety bugs often come down to code accessing data when it isn't supposed to. Since 2004, Microsoft has collected every reported security vulnerability, and this graph shows that about 70% of the vulnerabilities are memory safety issues, specifically developers inserting memory corruption bugs into their C and C++ code. Most programming languages today are memory safe because they use some sort of garbage collection, like our beloved JavaScript. But system level languages, which are languages used to build the underlying systems other software depends on, which can't afford a heavy runtime like a garbage collector, are usually not memory safe. With languages that are not memory safe, developers must manually manage their memory. And despite all the tools, linters, and code reviews in the world, as evidenced by the graph above, mistakes do happen. The way that Rust solves this is with the Rust compiler. When the code is run, the compiler will read through the code, and if it finds any code that breaks any rules, an error will be thrown in your face, and the code will not get to runtime, which will prevent mistakes from going into the universe. The only exception to this is if the developer needs to break the rules, there is an unsafe keyword where the compiler will let the naughty code compile. This also helps with troubleshooting because if there is a memory safety issue, the developer just has to look at the code with that unsafe keyword. The second issue is handling concurrent programming safely and efficiently. Concurrent programming is when different parts of a program execute independently, and parallel programming is when different parts of a program execute at the same time. And these properties are becoming increasingly important as more computers take advantage of their multiple processors. Historically, programming in these contexts has been difficult and error prone. On this slide, I list 3 common concurrency issues that Rust hopes to prevent. Initially, the Rust team thought that ensuring memory safety and preventing concurrency problems were 2 separate challenges to be solved with different methods. However, over time, the team discovered that the ownership and type systems are a powerful set of tools to help manage memory safety and concurrency problems. By leveraging ownership and type checking, many concurrency errors are compile time errors in Rust rather than runtime errors. Therefore, rather than making you spend lots of time trying to reproduce the exact circumstances under which a runtime concurrency bug occurred, incorrect code will refuse to compile and present an error explaining the problem. As a result, you can fix your code while you're working on it rather than after it has been shipped to production. The Rust team has nicknamed this aspect of Rust fearless concurrency. Fearless concurrency allows you to write code that is free of subtle bugs and is easy to refactor without introducing new bugs. One note is that with a single-threaded language like JavaScript, concurrency is achieved with asynchronous processing. Now for the third reason Rust was made, which was the lack of practical affordances. This was actually the first time I'd heard that phrase practical affordance, but after doing some internet sleuthing, I figured out that affordance means an obvious way of doing something. And I think the best example of this can be seen with the Rust error handling system. So here we have a code block written in Rust, and if we were to try and run it, the Rust compiler would serve us this error message. At the very top, we know what we did wrong. Then we'll know every place in the code where the violation occurred. Then we can dive further into the documentation if we're still lost. Since Rust requires that code must be written up to code, there will naturally be a lot of errors, but the error messages are robust and verbose and easily bring the horse to the watering can. The 3 things that we went over all work together to give the user total control of their resources. Because as Rust is so opinionated, if the code is able to run, the user by default will safely have control over all of their resources. And that is truly a beautiful sight. The last feature I want to mention is Cargo. Cargo is the Rust package manager. Cargo downloads your Rust packages dependencies, compiles your packages, makes distributable packages, and uploads them to Crate.io, the Rust community's package registry. It is a tool that allows Rust packages to declare their various dependencies and ensure that you'll always get a repeatable build. To accomplish this goal, Cargo does 4 things. It introduces 2 metadata files with various bits of package information. It fetches and builds your package's dependencies. It invokes rustc or another build to with the correct parameters to build your package. and it introduces conventions to make working with Rust packages easier. To a large extent, Cargo normalizes the commands needed to build a given program or library. That same command can be used to build different artifacts regardless of their names. An artifact is a file or set of files created as a result of the compilation process, and this includes linkable libraries, executable binaries, and generated documentation. Rather than invoke Rust-C directly, we can instead invoke something generic such as cargo build and let cargo worry about constructing the correct Rust-C invocation. Furthermore, cargo will automatically fetch from a registry any dependencies we have defined in our artifact and arrange for them to be incorporated into our build as needed. The last thing I'll say about the Rust package manager is that it was built by the Rust team, which is different from JavaScript, whose package managers are written by separate entities like NPM and Yarn. All right, so we have reached the second to last stop, the future of Rust. But with the backing of some big tech companies, Rust has many projects in the works. Just to list a few, both Microsoft and Amazon have recently announced and released their newly officially supported Rust libraries for interacting with Windows and AWS. Officially first-party support for these massive APIs helps make Rust the first choice when deciding what to use for on a project. The curl project has released new versions that offer opt-in support for using Rust libraries for handling HTTP, HTTPS, and TLS communications. Tokyo, which is an asynchronous runtime written in Rust, released its 1.0 version and announced their 3-year stability guarantee, providing everyone with a solid, stable foundation for writing reliable network applications without compromising speed. The critical section in Ferris Systems has started Ferrocene, which is a project to make Rust a viable programming language for safety and mission-critical systems across the industry. The Linux project is currently considering a proposal to add Rust as a second language to the kernel to enable writing safer driver and kernel space code. And Google has announced that they are rewriting their Bluetooth stack with Rust and now supports building low-level components of the Android OS in Rust. All right, so on the last stop, I have some resources share for you on your new Rust journey. If you want to learn about Rust, these are the great resources. Here we have the official documentation. And then we have a separate guide for noobs. We have the Rust Playground where you can experiment with Rust. We have an index of all the possible errors you'll get when you do play around with Rust. We have the documentation for the package manager, and we have the documentation for the keyword unsafe for those that like to live life dangerously. Well, we've reached the end of our journey. Thank you again to singlesprout and CodeSmith for letting me take this dive into the weeds of Rust, and thank you everybody for letting me take you on this trip. I hope you enjoyed the ride as much as I enjoyed driving, but please take a few minutes to connect with me on the LinkedIn.
Wonderful, wonderful job, Nick. Let's all unmute and give him a well-deserved round of applause for a fantastic presentation. Okay. Well, at this time, if anyone is interested in asking Nick any questions, feel free to do so. Just use the virtual raised hand feature. All right, if there are no questions, let's just give Nick one more round of applause. Great job, Nick.